Hello, and welcome to section 14. This section is our first look at transient circuits, and that's what we're going to spend a lot of the second half of the semester analyzing. So, kind of to get started, let's talk about what a transient circuit is before we do example 1. So, we have a normal circuit here, so we have a voltage source, 2 resistors, and if I start this thing up, what you'll see is down here you see a green bar. This green bar is the voltage across this 8 ohm resistor. And so it's 4 volts. You can figure that out using voltage divider. So what a transient circuit analysis is what happens when we turn things off and turn things on. So if I turn it off, well, the voltage drops to 0. If I turn it back on, it immediately jumps back up to 4 volts. So what we're going to be curious about is how long does this transition take? So in a circuit with only resistors, we find that the transition is instantaneous. It gets way more interesting when we put in those energy storage elements, so things like capacitors and inductors. When we put those in, these are no longer instantaneous jumps, they're curves. And so that's what we spend a lot of time analyzing is those curves. We want to know how fast do they rise, how long do they take to stabilize. Because you guys already know how to do analysis when you're in steady state, which would basically be the line up here at 4 volts or the line down here at 0 volts. So let's jump into that with example 1, just to kind of prove that it happens instantaneously. So example 1 says, if we turn off the voltage source at t equals 0 seconds, what is the new voltage V of x for t greater than 0? So this notation is very common for t greater than 0, because again, we want to transition. We want to know how long does it take after we do something. So generally we do things at, we consider 0 seconds. So we have our example drawn here. Again, you can work on notebook paper or just printer paper like I am here. Get that out of the way. So we have our 10 volts, our 2 ohms, and our 8 ohms, and our Vx is across our 8 ohms. So if we turn this off, it's the same thing as saying we now have 0 volts here. Here's our 2 ohms. Here is our 8 ohms. And here is our Vx. And all we want to do, the question asks us, what is V of x? So now that we're in our new state is at 0 volts. We've turned it off. So we can do that quickly with voltage divider. So that is just Vx equal to V Rx over Re. So in this case, our input voltage is 0, and Rx is 8, and Re is 2 plus 8, which is 10, but it doesn't really matter because we're going to multiply everything by 0, so we get 0 volts. And so we would write this as V of x is equal to 0 for t greater than 0, and that way we would box that as our answer. So we want to know, because a lot of times we're not going to get just a constant number. Again, this is a special case. Whenever you have just resistors, you're just going to instantaneously go to whatever the new state is. Most times they're going to be curves, so it'll be some function of t. All right. So in the next video, we will actually look at something that has a energy storage element in it.